Okay, so we're going to do a couple practice problems here. So this is just kind of showing that our double angle formula, right? So if I take cosine of 2 alpha or cosine of 2 theta and show that it's equal to one of the double angle formulas that we came up with. Okay, so I'm going to set up an algebraic statement, and I'm going to do this in black, and I'll do this in red, and I'll put them side by side. I'll do them one at a time, but I'll put them side by side. So cosine of 2 times 60 is the same as cosine of 120 degrees. We should know, oh, that's a 60-degree reference angle. It's in the second quadrant. And so because it's a 60-degree reference angle, this is going to equal -1/2. Okay? So let's do this. So I have 1 minus 2 sine squared alpha. And the way that I'm going to work this is I'm going to say, okay, well that's the same as 1 minus 2 times sine of alpha, or theta squared. Okay? So now I know my angle is 60 degrees. So a little bit more work for the basic angle, but it just shows you that they're the same thing, which is important. We need to see that. And so now, what's sine of 60 degrees? So 1 minus 2 sine of 60 degrees is √3/2. And I'm going to square it. So now it's just an algebra problem, right, or a basic computation problem. So that's going to be 1 minus 2 times, well, √3 squared is 3, and 2 squared is 4. So I get 3/4. These guys reduce, and I have 1 minus 3/2, which is equal to -1/2. So notice they're the same thing. And the problems aren't this easy, but you know, it's not going to be as cut and dry as this sometimes. But this is showing you that if I take an angle and double it, right, find the trig value, so that's what we did here, it's going to be the same as if I use one of these formulas. And if I used any one of the other formulas, it would end up being -1/2. So our next example is a little bit different than what we just got done with. And these are, you know, let's simplify the expression. So we're just getting practice with how we use our double angle formulas. So the first thing I need to identify is, well, basically is which formula. And in this problem, our formula is going to be cosine of 2 theta. Well, the second step is, what's theta equal to? Well, in this problem, theta is equal to 20 degrees. So step 3, plug in theta, or alpha. Okay, so I'm going to use this in my third step. Cosine of 2 times alpha, which is 20 degrees. And so this is cosine of 40 degrees. And it says do not evaluate in the problem, right? It says do not evaluate. So, and I can't evaluate it without a calculator, and that's our guide that says, okay, I'm done, that's my final answer. And so this is just a basic manipulation of going from one formula, or one part of the formula to the other. So we're going forwards and backwards. So kind of like the same stuff we've been working with. So here's our next example. What I would recommend doing is trying to do this on your own. We need to identify what the formula is, okay? And we'll go from there. So, and I'll actually, this one, I'll rewrite this so we get practice with sine, right? But, you know, what's the formula? So 1, I recognize that it's my double angle formula. 2, theta is equal to 35 degrees. And so 3 is, I take that 35 degrees and I plug it in, and so now my solution is 2 times 35, 70 degrees. That's it. It's not a nice angle measurement. Okay, so here's problem 2. What if I had this? What if I had 2 times sine of 35 degrees cosine 35 degrees? Well, I look at these aren't so nice, it's such a nice angle, and it's like, and I say do not evaluate. So the first step is, what formula is this? This is actually our sine formula. 2 is, what does alpha equal? It equals 35 degrees. Okay, so now the final step is I'm going to take that 35 degrees and plug it in for alpha, and I get sine of 70 degrees. So whether it's sine or cosine, the process is the same. Okay, so that's enough for this. This should be about 5-6 minutes or whatever, and there will be another video. Okay, so they're not all super long.